As we consider interesting applications of our knowledge of the adenylyl cyclase signaling cascade, we should go for a little bit of microbiology, and I want to talk to you about the cholera toxin. So many of you out there recognize that Vibrio cholerae is the bacterium that causes the watery diarrhea associated with cholera. And in fact, that's what typically tends to kill people who have cholera, is that excessive dehydration. So Vibrio cholerae is actually a kind of half-moon shaped bacterium, and it secretes a toxin that has two subunits. This toxin is often called choleragen, and I'm going to make the A subunit kind of a red color, and then the B subunit, I'll make it a blue color, and the blue subunit, or the B subunit, and the red subunit is the A subunit. So of course, like quaternary structure on that toxin. And what happens is that this is an enterotoxin. Sometimes it's just simply called CTX. And what it does is it comes over and it binds to a receptor on the surface of the gut cells. Now, this receptor, and we'll just make it a little black receptor here, and I should kind of make it look like it would be willing and able to bind to this donut-shaped B subunit. So that B subunit will bind to that receptor, and this will actually trigger receptor-mediated endocytosis. So we'll actually literally see an invagination. And if we can actually go ahead and give a little bit of a fill of a time lapse here. So receptor-mediated endocytosis is triggered. And then if we can go ahead and recognize that after this event has fully taken place, the cholera toxin gets inside of the cytosol. So now we have both the A and the B subunits that have been brought into the cell. And these actually get separated from one another so that the A subunit is then free to run off alone. And it has the ability to activate the alpha subunit of our transducer G protein that we've talked so much about. So then this becomes an activated GTP bound, and I'll just jot that down, GTP bound alpha subunit. And now because of its activation by the A subunit of the cholera toxin, it runs off and activates adenylyl cyclase signaling. And so the second messenger, cyclic AMP, is generated. So we'll just go ahead and jot down and maybe we'll just go ahead and get our adenylyl cyclase going on here, and recall that it triggers the formation of cyclic AMP, and now we have our cyclic AMP second messenger. And in this case, in the gut cells, this is going to cause a lot of ion efflux and fluid efflux, aka diarrhea. So isn't this a fascinating implication of our knowledge of adenylyl cyclase signaling cascades, as it can lead to the major deleterious outcome of having cholera?